Okay, it's 8 o'clock. Um, let's see. Tomorrow, exam. Hope everybody knows that by now. You can use your notes. You cannot use any kind of electronic device to help you take the exam. I must be able to see you on camera, okay? If I can't see you, I want grade your exam. And I'll set up a time where you can take it in Lucas. If you can't make that time, I'll have you take it on the day we have the final in Lucas. Okay, so any questions before we start first? Okay, we're going to spend today reviewing. I'm going to share my screen. Like the cat.
Sorry, Mahmoud. She was in my lap before we started class.
Yeah. What are the perks? Seeing everybody's cats and dogs and houses. Okay, so this is October 8th. Oh, I need my other glasses so I can see. There, yes, it's October 8th. And stop that. I'm going to spend today reviewing. I hope that you have looked at the practice exam, and I think taking it as if it were the exam would be a really good idea. And I hope you've already done that, because it should give you an idea of what you need to work on if you have trouble with something. Does anybody want to ask for a certain problem to be worked or a certain topic to be discussed?
Can we go over question 3?
Yes. Yeah, okay. Question 3. Okay, question 3 is a related rates problem. And let's see, so let's write it down. Rocket is launched vertically. And tracked by a radar station. Located on the ground 3 miles from the launch site. And of course, the radar station is not moving. It's the rocket that's moving. What is the vertical speed of the rocket? Stop that. Of the rocket at the instant that its distance From the radar station, it's 5 miles. Okay, my pen's not writing. All right, let's see. So something happened there. Let me go back. Oh, how about this? No. Okay, somebody entered the waiting room anyway. Okay, go back and there. All right, there. Okay, the isn't it? It's distance from the radar station is 5 miles. And this distance is increasing at the rate of 5,000 miles per hour. Okay. And that was a question. Okay, so picture. Here's where the rocket is launched from, that dot right there. And here's the radar station here. And let's see. The radar station is 3 miles from the launch site. And so LS for launch site, RS for radar station. Okay, and of course, launch site and radar station, that and the 3 miles, that's fixed, constant. You launch the rocket and it's going up. And the height is changing. Okay. And so is its distance from the radar station. So, okay. Yeah, the Pythagorean theorem comes in here. Let's call this H for height. And maybe I'll call this D of T, distance from the radar station. Okay, so what is the vertical speed of the rocket? So we want to know, yeah, the question is the vertical speed of the rocket. So that's if H is the height of the rocket at time t, then h prime is going to give you the vertical speed of the rocket. So this is h prime of t. All right, vertical speed of the rocket at the instance. Okay, so this is all changing, but at one instant, the rocket is 5 miles from the radar station. So that's one moment in time. I'm making this a little red rectangle. At one moment in time, well, this is 3. And distance from the radar station is 5 miles. Okay. So at this moment in time, the hypotenuse is 5. And that means that, well, this side is 4, right? Because 3 squared plus 4 squared has to be equal to 5 squared. Okay. That's just one moment in time. The height of the rocket is changing. The distance of the rocket from the radar station is changing. So what do we have? We have that 3 squared in general. Let's go back to black. Three squared plus h squared is d squared. And h is a function of time, d is a function of time. That is, they are changing. Okay, the 3 is not. So here's your basic relationship between height and distance. And we want to know what h prime is. Okay. All right. Oh, yeah. We're also given this little piece of information. The distance is increasing at the rate of 5,000 miles per hour. So at this moment in time, d prime of t is 5,000. This is a specific moment in time. But the relationships are more complicated than that one moment in time. Okay, the basic relationship is 3 squared plus h squared is d squared. Let's differentiate that equation implicitly. Remember, h is a function and d is a function. So differentiating, we have 0, derivative of 3 squared is 0. What's the derivative of h squared?
It would be 2h, but 1 to the 5,000 be the derivative of ht, of h prime t, because isn't that for finding the speed from the ground?
Okay. All right. Let's see. Let's read the problem again. Okay.
Never mind.
Never mind. Yeah, we want to find, let's see, what is the vertical speed of the rocket? We want to find h prime. Okay. At this one instant in time. But yeah, h represents the vertical height of the rocket at time t. D represents the distance from the rocket to the radar station. Okay, so was somebody trying to get in? Something just flashed across my screen there. I didn't quite see it. Yes, somebody did. All right. Okay. But no, what's the derivative of h squared, Mr. Levy?
I'm sorry, ma'am. I was a bit confused. For whatever reason, I had thought that the question had the 5,000 miles per hour being the speed at which h of t was increasing by.
Okay. Oh, well, you could work that problem too. But the way I read it, okay, this is talking about the distance from the radar station, and this distance, the distance from the radar station is increasing at 5,000 miles per hour. But let's go back to what's the derivative of h squared? It's not just 2a.
Wouldn't that 3 miles be 5 miles actually?
No.
Hmm?
No, but the 3 miles is the distance from the
Distance from the radar station is 5 miles. Oh.
no, the distance from the
Oh.
radar station is to the launch site is 3 miles.
Oh, my bad. I was reading the wrong part.
Okay. Okay, so somebody tell me what the derivative of h squared is. It's not just 2h. Something's missing.
Would it be 2h h prime?
Yeah. 2h h prime, or you can write DHCT too. That's another notation. Okay, what's the derivative of d squared?
It would probably be 2d prime.
Yes. Okay. And that's because h and d are functions. They're not just independent variables. Okay, so the relationship here in general, in fact, this applies for all moments in time, as long as the rocket's going up, is that h prime is 2, okay, I'm dividing out the 2, is d prime. Okay, we want to know that, the h prime. We are given, okay, that at this particular moment in time, d is 5 and d prime is 5,000. And we also know from the Pythagorean theorem that that means that at that moment in time, h is 4. Let's emphasize, at this instant. These are what we're going to put in. So we're only going to get h prime at one moment in time. H prime then is d prime over h, which is, okay, d is 5, d prime is 5,000, and h is 4. And okay, as far as I'm concerned, you can leave your answer in this form. I don't particularly want you wasting time doing arithmetic. But okay, let's at least multiply the top out. This is 25,000 over 4. And I'm not going to go any further than that. It's not terribly tough, but whatever. Actually, it goes an even number of times, doesn't it? Okay. 125,000 over 2, which is 625. Yeah. $62,500. Did I? All right. Oh, okay. Okay.
Wouldn't that be 12,500?
Okay. I divided 2. Okay. Why don't I should have just left it there. Okay. Oh, that is 5 times 5,000 is 25,000, right? So 4 goes into 25 6 times. 24, 10, 2, 8. Bring down a 0. That's 20. 5. Okay, so go down that 0. And then there's that one. And 4 goes into 250 times. Okay, there's too many zeros there. Okay. So at this moment in time, D prime, not D prime, H prime. Remember what the question was. H prime of T is 6250 miles per hour. That makes more sense. Okay. Okay. Yeah, another question. Would you like to see something else worked out on the practice exam? Now, the practice exam is not going to be your exam, so that you should study more than just the practice exam. You should make sure that if you're having trouble with some of these problems, look up some problems in your text or some text, or similar ones until you feel comfortable. Okay.
Excuse me, Dr. Kennedy. I have a question.
Okay.
I just want to know, how did you get that number 4? I'm a little confused about it.
That number 4?
Yeah,
Oh,
the number 4 in that 3 squared plus 4 squared equals 5 squared. I just want to know how did you get that?
Pythagorean theorem. Oh, well, okay.
Yeah.
Yeah. So 5 squared, well, you didn't know this to start with. So, but 5 squared, somebody is trying to get in. 5 squared minus 3 squared would be 16. 25.
Oh, okay.
Okay.
No, I got it.
Okay.
Okay,
Good.
thank you. I understand that.
Okay. Well, if no other questions, how about an implicit differentiation?
Dr. Kennedy, I have a question about the problem we just did.
Okay.
I just wanted to ask, like, looking at this problem, what is the thing that's going to pop out to me to tell me to use what we just did, like, besides the Pythagorean theorem, like using the H prime and the D prime?
Well, okay. There is no set way to set these problems up. There are different relationships involved. Sometimes it's a Pythagorean theorem. Sometimes it's similar triangles. Sometimes it's a volume that's changing or an area that's changing. It can be a gazillion things. This one, yeah, you've got to read the problem carefully first.
Mm-hmm.
I would suggest drawing a picture. Pictures help. And then if it's not explicitly given in the problem, figure out what relationship it is that you need to use. And you just go from there. You've got to identify what you are given in the problem. And you've got to identify what the problem is asking you to find. But you take them on a one-by-one basis. We could, if that's what you all would like, we could work another related rates problem.
I'm okay with it if everyone else is. I don't want to waste our time though.
It's not a waste of time. Yeah, and that's the case with a lot of the things we're going to do. It's going to be on a problem by problem basis. And in fact, I actually gave you on this exam, hint, use a Pythagorean theorem. Okay. So I basically told you what the basic relationship is here, what the basic equation is. Yeah, if I give you a hint, use it. Okay, let's do an implicit differentiation. And I'm not gonna do the one on the exam. Okay, differentiate implicitly. To find dy dx So I'm thinking of y as a function of x in terms of x and y. Okay, how about this? Tangent of x plus tangent of y is equal to x squared. Okay, and I I have no idea if, well, I'm not for sure that this defines, if at any point satisfy this. I just made this up. Okay, so let's not worry about that. We can still theoretically find dy dx. Okay, so y is a function, x is the independent variable. I'm going to differentiate both sides. Let's start with the easy side. What's the derivative of x squared?
Two X.
2x. What's the derivative of the tangent of x?
Secant squared x.
Yes. What's the derivative of the tangent of y?
It would be secant squared y prime.
Good. Okay, good. Secant squared y prime. Yeah, it's the chain rule. Okay, you've got y is inside the tangent. So you got a function inside of a function. And that means chain rule. So derivative of tangent is secant squared. That gets applied to the inside function. And then you multiply it by the derivative of the inside function. Okay, so we got our basic derivative here. You can always, it turns out, solve for y prime in terms of x and y. And here it's not too hard. Let's see. So we've got secant squared x. I'm going to I'm going to put the non-y prime terms on one side and the y prime terms on the other. In fact, let's keep the y prime terms on the left. So secant squared of y times y prime is 2x. Whoops. Okay. Uh,
2x minus secant squared x.
yes. Okay. And then to get y prime by itself, I just need to divide out the secant squared. So there you have it. Okay. Well, as long as we're here, let's do the one on the exam. So this is A and B, same instructions. Find dy dx. We have x to the fourth plus y to the fourth is equal to 4xy. Differentiate both sides. Derivative of x to the fourth, 4x cubed. Derivative of y to the fourth, 4y cubed y prime. Again, here y is inside the raising to the fourth function. Okay, what am I going to do on the right-hand side? What do I need to use? Nobody?
You would need
Product
to
rule.
use
Product rule, yes. Okay, that's a product, okay, of 4x times y. So we need to use the product rule here. Okay, so that means, I'll come down the line here. Derivative of 4x is 4 multiplied by y plus 4x times the derivative of y. And that's the product rule. Okay, there's our basic relationship there. We can solve for y prime now. Okay, I'm going to keep y prime terms on the left and not y prime terms on the right. So we got a y prime there and a y prime there. And it's going to be 4y minus 4x cubed. And then you can, once you have, yeah, every term on the left has a y prime as a factor. So I can factor it out. And so then you have y prime is 4y minus 4x cubed over 4y cubed minus 4x. You will definitely have an implicit differentiation problem on the exam. You will definitely have a related rates problem on the exam. You'll definitely be have a problem like number 1, where you just are using the differentiation rules. You'll definitely have a tangent line problem. And okay, I also, this practice exam did not have a velocity problem. There will be a velocity problem on there tomorrow too. Okay, so you know what's going to be covered. Could we have another request for something? Some kind of a problem.
Well, ma'am, could we also go over something similar to number 6?
Yeah.
And also, before we do so, couldn't you also remove all of the fours in that last function?
All of the 4s?
Yes, ma'am. Like, wouldn't they cancel out?
The last function. Okay, you mean that x squared plus y squared is 100?
Yes, ma'am. That was when I was wanting to go over, but kind of what I
Yeah.
meant was like in the one we just solved, wouldn't it be possible to translate it or simplify into y minus x cubed over y cubed minus x, since all of those values have 4 connected to them?
Okay, I'm confused. Are we talking about problem 6?
No, that was meant more for question number 2, which we had just went over.
Oh, question number 2. They all have 4s. Oh yeah, you could divide that 4 out. Sure. You're talking about this. Okay. Yeah, of course you could.
Okay, thank you.
Okay, well, let's do this problem. This is problem 6. Find all points. This is a circle. A squared plus y squared is 100, with the slope of the tangent line is 3/4. So let's draw a picture. Other than the fact that this circle has a radius of 10. basically a tangent line problem. Okay, yeah. Okay, well, the slope of the tangent line is 3/4 points on that circle where the slope of the tangent line is 3/4. There are points on the circle where the tangent line is any number. Okay, the slope takes on all values. So there's a couple of places where the slope is infinite, so not a number. But so we're looking for 2 points at least. The tangent is positive in the first quadrant and the third quadrant. So there's some point over here where the tangent line's going to have, whoops. Nope, that's not true. It's negative in the first and the third. So it looks like that line has negative slope. Okay. It'll be over here or over here. So in the second and the fourth quadrants. So I'm looking for 2 points, just looking at the picture of the circle. Okay. But, and we could solve for y explicitly and get the upper function and the lower function. But we can also just differentiate implicitly. So 2x plus 2y prime is 0 from, okay, that's differentiating x squared plus y squared equals to 100 implicitly for y prime. And that says that, well, I can divide out the 2's right there. Y prime is minus x. So y prime is minus x over y. And okay, and we want the points where y prime is 3/4. Okay, the slope of the tangent line, remember, is the derivative at that point. Y prime is 3/4, that's equal to minus x over y. And let's see, so let me do a triangle. So, okay, well, looks kind of obvious. Okay, let's see, well, I can solve for y. Y is plus or minus the square root of 1 minus x squared, up 100 minus x squared. Let's work it out. And so 3/4. Okay, one possibility is it's minus x over the square root of 100 minus x squared. And then the other, use other function, that says that 3 times the square root of 100 minus x squared is minus 4x. Square both sides. 9 times 100 minus x squared is 16x squared. So 100 minus 9x squared is 16x squared. So 100 is 25x squared. This was rigged. Come out nicely. 4 is x squared. X is plus or minus 2. Okay, if x is plus 2, then y, let's what's the square root of, I'm using the plus one here. That's going to be the square root of 100 minus 4. Which is the square root of 96. And okay, that works for both plus 2 and the minus 2. Is that, okay, so that
Should the
says,
9 be distributed to both the 100 and the negative x squared?
okay, that doesn't look right. Yeah, what was the, what was the question?
I said, shouldn't the 9 be distributed to both the 100 and the negative x squared?
Yes. Thank you.
You're welcome.
Yeah, that looks a little strange. Okay, so let's go back and fix that. That's supposed to be a 9. I don't want yellow. Okay, that makes that 900. So 900 over 25. 900 over 25. Okay, 25 goes into 100 4 times. So that's 9 times 4, which is 36. Okay. Okay. Now keep checking me, you guys. That looks a lot more reasonable. That says that 6 is x, 6 plus or minus 6. And all right, so what was the question now? Okay, so you were looking for y. We've got 3/4. Oh, we were working on that. We've got x. Okay, so x is 6 plus or minus 6. That means that y, we're using the plus possibility. Y was equal to plus or minus the square root of 100 minus x squared. Okay. So that'd be 100 minus 36. And let's see, 100 minus 36 is 64. Yes. Equals to plus or minus 8. Okay, and that would give me the same result regardless. So let's see, 3/4 is supposed to be minus x over y. And we have, okay, plus or minus 6 for x, plus or minus 8 for y. Only 2 of those possibilities are going to hold. The one for that's in the second quadrant and the fourth quadrant. But okay, so let's see. If we take x equal to minus 6, so that would correspond to the second quadrant, then minus 6, which is a positive number, so I should take plus 8. Okay, and that is equal to plus 3 over 4. So x is minus 6, y is 8 is one possibility. That is this point, okay, right there, minus 6 plus 8. And the other one has to be how about x is 6 and y is minus 8. Okay, because that's going to correspond to the fourth quadrant. And let's check. 3/4 is supposed to be equal to minus x over y is minus 6 over minus 8, and that is indeed 3/4, so check's fine. Okay. Well, thank you for the help. Yeah, so we got that point too. That point is 6 minus 8. And they would be exactly opposite each other on the circle. And that's what we got. Oh, that's a cute little problem. We have about 10 minutes left. How about a couple of derivatives? There's some to practice on the exam, but let me just make up some problems. Oh, let's see. If I asked you for this derivative, what would you use?
Quotient rule?
Quotient rule, yes. Or, well, you could use a product rule if you wrote it differently, but let's go with the quotient rule. Okay, derivative of the top. Yeah, you're allowed to use your notes, but you really ought to memorize these things. In fact, if you've used these things a couple of million times, I sort of remember them anyway. Derivative of the top function times the bottom function minus the derivative of the bottom function times the top function. Over the bottom function squared. Okay, so the derivative of 3x squared plus 1, that's pretty easy. That's just 6x times x plus 2. And then the derivative of x plus 2, that's pretty easy. That's just 1. Okay, now that's the derivative right there. And if you want to leave it there tomorrow, that's fine. I want to see tomorrow that you can use the differentiation rules correctly. Right now we're talking about curve sketching. Okay. And when you're doing curve sketching, you're going to want to simplify these derivatives and do the algebra necessary. But for tomorrow, I want to see whether you can use the differentiation rules correctly. And I do expect you to show your work, give reasons. I want to see that you understand what you are doing. Sometimes if I just see a correct answer and there's no work to back it up, I count the entire problem wrong. Show me. Okay, but if you wanted to write it in a little bit nicer form, that's 6x times, well, let's multiply it out and write it again. 6x times x plus 2 would be 6x squared plus 12x minus 3x squared. Okay, that minus applies to both. I've got the 3x squared plus 1 in parentheses. That means this minus applies to that 1 too when I distribute. Okay, so let me erase the parentheses. That's 3x squared minus 1 over x plus 2 squared. And I'm not going to expand that x plus 2 squared. Sometimes it's better to have something written as a product. Kind of depends, but I'm just going to leave it the way it is. Okay, so what do I have on top? I've got 6x squared minus 3x squared. That's 3x squared. And then I've got a 12x and a -1. I don't think that factors in a nice way over x plus 2 squared. So this is, that would be a correct answer. That would be a correct answer. That would be a correct answer. Okay. How about a chain rule problem? In fact, I'm going to make it secant of the sine of x. Okay, so the sine of x is inside the secant function. It's not, this is not multiplied. This is a composite. If it were multiplied, okay, it would look different. If it were a product, it would be secant x times sine x. That's a product. This is a composite. Okay, so we'll differentiate both of these. The derivative of the secant of the sine of x. Okay, let's break it down. Once you get comfortable, maybe you have to go through this, but you can always do it. The inside function, call it u, is the sine of x. The outside is the secant of u. Okay, so the derivative of u is cosine of x. Okay, that's u prime. And the derivative of the secant of u with respect to x. Ooh, does anybody remember what that derivative is?
It would be secant x times so 10x.
Yeah, only instead of x is u. Oh, in fact, I wrote that incorrectly. Okay. That should be du. So it's secant u, tangent u. Okay, so putting all that together, remember it's the derivative. Oh, I'll use capital T. I'm running out of time real fast here. Finish this, call it a day. The derivative of f of g of x is f prime of g of x times g prime of x, and u is the g of x. Okay, so it's f prime of u times g prime. Okay, so the derivative of the outside function secant u tangent u times the derivative of the inside function, which is cosine of x. And then you put u back into your x back into that. So secant, I'm not writing very well here. Secant of sine, tangent of sine times cosine of x. That would be the derivative. And I am definitely out of time, so I will end class. Yeah, you can start tomorrow early. I have arranged on Blackboard for the exam to appear at 7:30. Okay, and I will open class then. Give you some extra time. And also hopefully it'll mean that the exams don't all come in at the same time. Get a pile up. So yeah, take advantage of it. Use the extra time if you need it.
Thank you, Professor.
Yeah. You're welcome. I'll see you all tomorrow.
Thank you. Bye.
Have a good day.
You too.